What's up guys, it's Simon Fiaz and today's video is on AQA Level Chemistry 2020 Paper 3 Multiple Choice Question Section B. Question 7. When heated, a sample of potassium chlorate produced this much oxygen, this much was the amount of moles that has decomposed, or potassium chlorate that decomposed. So, first thing I would do is, obviously I'm going to be using PV because nRT, the ideal gas equation. Therefore N equals PV divided by RT, which is pressure 1000 times by the volume. Volume always needs to measure in meters cubed, so 67.2 times by 10 to the power minus 6 divided by million divided by 8.31 times by the temperature in Kelvin, 298 Kelvin. So I get 110123 by 67.2 times by 10 to the power minus 6 divided by 8.31 times by 298 Kelvin. I get 2.99 times by 10 to the power minus 3. But it says what's the amount of moles of potassium chlorate that has been decomposed. 110,000 times by 67.2 times by 10 to the power minus 6. 8.31 times by 298 Kelvin. What is the amount of moles of potassium chlorate that has decomposed? Yeah, I don't know what's going on with this question. Oh, right. Right. That's really sneaky, but they're giving me the volume of oxygen. So what I just did, this whole process of converting the units, putting into this equation, I've got the moles of oxygen, but I want the moles of potassium chlorate 5 that has been decomposed, So if I've got the moles of oxygen as what did I get? 2.99 times by 10 to the power minus 3. Then I divide it by 3 and then 10 by 2. 1.99 times by 10 to the power minus 3. That's really sneaky because you're given the volume of oxygen, therefore that's the moles of oxygen and 2 to 3 mole ratio, and then you get the moles of potassium chlorate 5. Question 8, which has a bond angle of 109.5 degrees. It's obviously going to be, diamond, carbon diamond. Question 9, Which reaction is the enthalpy change equal to standard enthalpy formation silver iodide? Well, it's definitely not going to be these two because these are ions, and therefore it's going to be B because Ag is a solid, it's not a gaseous. That's the correct standard state. Question 10, some bond enthalpies are given. What is the enthalpy change of this reaction? Kilojoules per mole to power minus 1. And bond enthalpy is given in kilojoules per mole to power minus 1. So it's energy required to break bonds minus energy released when new bonds are formed. So to require to break bonds, 412 times by 4 plus O2 2 times by 496 minus carbon dioxide 743 plus 743 plus H2O. Well, I've got 436 plus 436, and then I've got times by 2 on the outside. So just a lot of printing. Calculate, make sure you don't do anything wrong. So the first part, energy required to break bonds, is 2640 minus 3338, and I should get minus 698. So therefore the answer is D for question 10. It was something like, yeah, minus 3338 minus 698. In which conversion is the metal reduced? Metal reduced. So then here, minus 14, minus 2 times by 7 minus 14, minus 14, that's plus 6, minus 8, that's also plus 6. Minus 8, because oxygen minus 2 times by 4, minus 8, that's plus 7, minus 1 charge, minus 2 times 4, minus 8, that's plus 6. Oxygen minus 6, plus 4, plus 4, minus 2, that's plus 2, oh no, that's minus 2, it's going to be plus 4 then, minus 6, plus 5, so which one is metal reduced, aka oxidation state goes down, it's going to be D. VO3 minus to VO2 plus. Question 12, the rate expression for the reaction between X and Y is this. Which term is correct? The rate constant has units there. I'll check that in a bit. The rate of reaction is halved if the concentration of X is halved and the concentration of Y is double. Well, if concentration of X is halved, a half squared times by concentration of Y is doubled, half squared times by 2, the reaction is halved. Yes, so therefore the answer must be B. Question 13, which statement about pH is correct? The pH of a weak base is independent of temperature. pH of this much of nitric acid is approximately 0.30. Let's find out the pH of that. Minus log 10 concentration H plus nitric acid. So, minus log no, it's not. It's minus 0.30. pH of this much of sulfuric acid is greater than this much of that. Well, minus log 10 of 0.10 times by 2, 0.70. That's 1. So no, because HCl is 1 and sulfuric acid is 0.70. pH of a weak base is independent of temperature. No, it is dependent of temperature on temperature. Therefore, the answer must be at temperatures above 298 Kelvin, the pH of pure water is less than 7. And that makes sense because if we increase the temperature above 298 Kelvin, the pH of pure water is less than 7 because the concentration of H plus ions is going to increase, right? So, yeah. 13b. Question 14. Which acid-base pair has the highest pH at the equivalence point? So, first one, methane, ethane, ethanoic acid, and sodium hydroxide. Ethanoic acid, but sodium hydroxide, no. Then let's look at C, HCl and sodium hydroxide. HCl is weak acid. So we can already eliminate A and D because they're both weak acids. I'm left with A and B, and I eliminated A because of the sodium hydroxide. That's weak as well. This ammonia, yes, that will has the highest pH at the equivalence point. No, sorry. Don't know what's wrong with me today. I shouldn't say that. HCl and this one, because both HCl is weak acid, so I'm left with A and B. Well, NH3, the highest pH, so is going to be sodium hydroxide. Because NH3, even though is alkaline, it is a base, it's just not going to produce the highest pH at the equivalence point. Therefore, the answer is A. Question 15. Why is nitric acid added? It prevents the precipitation of silver compounds other than halides. Question 16. Which shows a major product form when chlorine reacts with dilute aqueous sodium hydroxide? O plus H2O. Yeah. NaClO, NaCl, NaCl, NaClO plus H2O. Yeah. So the major product, so NaCl, NaClO. So therefore C. An equation you have to memorize. Question 17, which shows the electron configuration of an atom of a transition metal. Now it's not going to have a full 3d10 orbital, and it's not going to be completely empty. It's going to be almost full. So B. Which will not act as a ligand in the formation of a complex ion. So it's a donator, right? CH4, which will not act as a ligand. So okay, which one does not have the lone pair of electrons? Gotta think deeply for these kind of questions. Lone pair of electrons. NH3 will, NH3 with lone pair of electrons. H2O, definitely two lone pair of electrons. Carbon monoxide will have the lone pair of electrons. CH4 definitely won't, because carbon can only form 4 bonds. Question 19, which shows the correct oxidation state and coordination number of cobalt in this. I haven't actually gone through coordination number in a while, but the oxidation state of cobalt, well, NH3 is going to be D then, because NH3 plus yeah, let's skip that one. I haven't gone through coordination number. I've gone through oxidation states with like these compounds, but not the coordination number. Which statement is not correct? Which statement is not correct? Which statement is false? CuCl42 minus is square planar. NH4 plus is tetrahedral. Yes, it is tetrahedral, so that is correct. So it's not the incorrect one. That is octahedral. That is A. CuCl42 minus square planar. False. Is not square planar. 21. Which compound discolorizes acidified potassium manganate 7 solution? Which one decolorizes it? Now I've got these four different compounds. It's going to be FeSO4 then. FeSO4. So therefore C is the correct answer. Definitely not that one, definitely not that one, definitely not that one. C21C. Question 22, which one has EZ isomers? Now, let's look at the first one. Excuse me. Look at the second one. Look at the third one. H. And look at the fourth one. Let's just put 2 there. PR there. Put 2 there. Which one has EZ isomers? So, in order for it to have EZ isomers, it's got to be 2 different groups, right? I look at B. That appears twice on both sides. It can't be B. 3 of them are the same. If I look at C, same thing. I must have drawn C incorrect, but yeah, same thing. Same thing with D. But if I look at A, it looks like it doesn't have EZ isomers, right? But in reality, it does. Because what you can do is you can put this here, the Br where the hydrogen is, hydrogen where the Br is, and you can have, or you could swap that. You could have Z isomerism, and you can have E isomerism. Yeah, so that will have E-Z isomers. So 22A. Question 23, which is the mechanism for this conversion? Addition, elimination, definitely not, because then I'll end up with what's it called, like a double bond O and stuff like that. Electrophilic substitution, no, that's with the NO2. I'd get an NO2 group. Free radical substitution, definitely, yeah. I've gone from CH3 to CH3 to CH2Cl, so definitely free radical substitution, definitely not nucleophilic substitution. Question 24, which compound decolors bromine water in absence of sunlight? Decolors bromine water, so we've got to have carbon-carbon double bond. So it's not going to be A because that's a halogen alkane. B, C6H6 benzene, got no double bonds. C, that's cyclomethane, ethane, propane, butane, pentane, hexane, that's also got no double bonds. D, it must be D, and it doesn't look like it has double bonds really, but if it's 1, 2, 3, 1, 2, 3, 4, C4H, 1, 2, 3, 4, 5, 6, 7, 8. Perfect. And that's why there's only one hydrogen there, because it's got a double bond. Which compound reacts to form a ketone when warmed with acidified solution of potassium dichromate? Which compound reacts to form a ketone? Well, secondary alcohols. Dairy alcohols oxidize to form your ketones. So it can't be D, because that's a carboxylic acid. It can't be C, because that's an aldehyde. Yeah, so I'm left with A and B. Okay, if I look at B, CH3 2, so I've got, just draw it out, CH3, 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 CH, CH3. Okay, now I'll put a carbon here. I have CH3, CH3. And then I'm going to have a hydrogen here. And then my OH group attached to it. And instead of that, because that can't be possible, it's going to have a CH3 here and then a CH3 here. That's what's going to be happening. And if you look at that, that is a secondary alcohol, therefore will be oxidized. Or, you know it's not C and D because C is an aldehyde, D is a carboxylic acid. So then you look at A, and if you draw out A, that's a primary alcohol. And primary alcohol oxidized from aldehydes are not a ketone, so it definitely can't be A. Therefore, you're left with B via trial and error or elimination, which does not contain an asymmetric carbon atom. Which does not contain an asymmetric carbon atom. So which basically contains a symmetric carbon atom. It's definitely not going to be C. That can't be. That can't be symmetrical. Which one does not contain asymmetric? Yeah, that does contain asymmetric. Definitely can't be D because that there. There's nothing there. Nothing A and B. If you draw A out, CH. So I've got CH3, CH3, CH and methyl group, sorry, and then CH2, CH3. Yeah, it's going to be A. That does not contain an asymmetric carbon atom. Question 7, which reaction involves addition and elimination? The first one, potassium hydroxide to form an alkene plus that's elimination. Not addition, not nucleophilic addition elimination. The second one, well, let's go to the third one. The third one, alkene plus chlorine to form that's electrophilic addition. And the fourth one, nucleophilic substitution, everyone must be B, and it makes sense. You've got your chloride, ethanol chloride, or yeah, plus that to form that plus HCl. Question 28. Which compound reacts with hydrogen bromide to give 2-bromo 3-methyl butane as the major product? So 2-bromo 3-methyl butane as a major product. Well, where the double bond is, that's when I'm going to have my Br and the hydrogen, right? So, first one, 2-bromo, yeah, but I'm not going to have 3-methyl butane. Yeah, definitely not. Second one, 2-bromo, but then the third one I've got CH2, so that's not methyl in the third carbon. This one, 2-bromo, same thing. I'm not going to have the methyl in the third carbon. If it must be D, if look, that's 2-bromo. And then the third carbon, yes, I will have the methyl group. Therefore, the answer is 28D. Question 29, which forms a polymer with that? It's obviously going to be A. Definitely not this anhydride. Definitely not that. I don't know what that is. Or the NH2 carboxylic acid. No, because they've got the same. That's the same. These two have got to be the same as well to form that with that. To form a polymer with that. So 29A. Question 30. Which structure shows the Zwitter ion of an amino acid? Zwitter ion contains a positive ion and a negative ion, right? But it's only got two. So I can cross out A, because that's got 3 charges. I can cross out B, that's got 3. I can only have 2 charges. I'm left with C and D. Well, the answer is going to be... Yeah, the answer is going to be D. Because I can't have... This remains unchanged. I can't have the thingy here with the positive charge. Therefore, the answer must be D. Question 31. What is the minimum volume in centimeters cubed of this much needed to oxidize this much of VO2 plus? What is the minimum volume of this much needed to oxidize this much? 0.01. So I've got 0.02 moles per minus cube of that needed to oxidize that much of VO2 plus. Well, first thing I can notice is that I've got the minimum volume centimeters cube. I've got this in moles per minus cube, so I need to convert the moles per minus cube into centimeters cube. So 1, 2. So basically 1, 2, 3. So that's 20. Right, and I want the minimum volume of this need to oxidize this much of VO2 plus. Well, then the 1 to 5 to 1 mole ratio, so times that by 5, that's 100. That's the minimum volume needed to oxidize this much of that. So therefore the answer must be C. Just remember to convert your units. 0.02 moles per minus cubed is times by 1000, 1, 2, 3, 20 centimeters cubed. Question 32. Which is the concentration of sodium hydroxide as a pH that? Kw is that. So first thing I would write Kw concentration H plus and the concentration OH minus and the concentration OH minus equals Kw divided by concentration H plus. I've got Kw. I found out concentration H plus. I'm going to use concentration H plus equals 10 to the power minus pH and then work from there. So it's going to be 1.00 times by 10 to the power minus 14 divided by 10 to the power minus 14.30. I get 1. Well, it's going to be 2.0, 1.995, so therefore 2.00. Do question 32D. Question 33, what are the units of the rate constant for third order reaction? Now, what I would do for this is construct it. Let's, for example, third order reaction, rate equals K, Y, third order to power 3. Find out K equals rate. What's rate? Moles per dm minus cube S power minus 1 over moles per dm minus cubed. And then I'll get moles per dm minus cubed S to the power minus 1 over mol to power 3 dm to power minus 9. Actually, no, I leave it as moles per dm minus cubed. That will cancel out, and then I'll be left with S to the power minus 1 over moles dm minus cubed squared, mol to power 2 dm to power minus 6. And then therefore it's going to be mol to power minus 2 dm6 S to power minus 1. Yeah, because that's under the bracket, that's the denominator, so mol to power minus 2 dm6 S to power minus 1, so 33D. Question 34. what is the pH of this much of sulfuric acid? The thing about sulfuric acid is diprotic. That's the main thing, trick part to this question. Once you spotted that out, you draw it out, then yeah, you've got it in the bag. 0.015, and then times it by 2 then, 0.030, and then pH equals minus log 10, the concentration of H plus, and then you just substitute into there, minus log 10, 0.030, 1.52. Don't forget the answer is C, 34C. Question 35, which compound is formed when phenyl benzene carboxylate is hydrolyzed under acidic conditions? Phenyl benzene carboxylate is what? An ester. So I'm doing an ester plus H2O hydrolyzed, H plus, reflux, reversible reaction at equilibrium, then I form alcohol, and alcohol plus the carboxylic acid. So when I first attempted this question, I was like, oh, I just find out whichever one's alcohol carboxylic acid. So B, that's an aldehyde, C, that's a ketone. But in reality, I've got A and D, but one A's an alcohol, D is carboxylic acid, right? But therefore the answer is going to be A, because that's C6H5CH2OH, not just going to be C6H5COOH. That's not going to be correct. It's going to be C6H5CH2OH. 35. 34C, 35. Let's go. Let's have done a mistake. Phenyl benzene carboxylate. Yeah, never mind. I won't form that. I will form D. C6H5COOH. Definitely not that, definitely not that. There's a 50-50 chance it's not going to be that. It's going to be C6H5COOH. The final one, should rinse apparatus before starting acid-base titration. The results of titration showed that the volume of acid added from the burette was larger than expected, which is a possible reason for this. The idea that the burette was rinsed only with water. The burette was rinsed only with water. And that is the end of section B and the multiple choice questions.